Before we begin, make sure you watch this video all the way to the end, because what you're about to hear might completely change how you think about our place in the universe. Imagine looking up at the night sky and realizing that something invisible, something impossibly dense and powerful, is silently drifting toward our solar system. No explosion, no warning signal, just a dark object moving through space. A black hole. And not one sitting safely at the center of a distant galaxy, but one passing directly through our cosmic neighborhood. What would actually happen if a black hole traveled through the solar system? The first thing to understand is that black holes are not cosmic vacuum cleaners that instantly suck everything in from a distance. Their gravitational pull, at a distance, behaves just like any other object with the same mass. So if you replaced the Sun with a black hole of equal mass, the planets would continue orbiting almost exactly as they do now. The difference would be the absence of sunlight, which would eventually freeze the entire solar system, but the orbits themselves would remain stable. But that's not the scenario we're exploring. We're imagining a rogue black hole, one that is not bound to any star, passing through the solar system from interstellar space. These objects likely exist. Some may have been ejected from galaxies during violent interactions or formed in isolation. They wander the galaxy silently, nearly impossible to detect unless they interact with something. As this black hole approaches the outer edges of the solar system, the first region it would encounter is the Oort cloud, a vast spherical halo of icy objects that extends far beyond Pluto. The gravitational influence of the black hole would begin to disturb these distant objects. Some would be pulled inward, becoming long-period comets heading toward the inner solar system. Others might be flung out into interstellar space, permanently lost. At this stage, nothing dramatic would be visible from Earth. The black hole itself emits no light. Unless it's actively feeding on matter, it would remain completely dark. But its gravitational fingerprints would already be reshaping the outer solar system in subtle but significant ways. As the black hole continues its journey inward, its influence becomes stronger. It begins to affect the orbits of distant dwarf planets and icy bodies beyond Neptune. Over time, these orbits would become unstable. Some objects might collide, others might be ejected, and some could be redirected toward the inner planets. Now imagine the black hole moving closer, entering the region of the giant planets. Jupiter, Saturn, Uranus, and Neptune are massive enough to feel its presence strongly. Their orbits could be altered, stretched, or tilted depending on the path of the black hole. Even a slight change in Jupiter's orbit could have cascading effects throughout the solar system, because Jupiter plays a key role in stabilizing the orbits of other bodies. If the black hole passes relatively far away, the effects might be limited to orbital disturbances. But if it comes closer, the consequences become far more dramatic. The gravitational interaction between the black hole and the planets could lead to chaotic motion. Planets might shift into new orbits, potentially crossing paths with each other. Collisions, while still rare on human timescales, would become more likely. As the black hole approaches the inner solar system, things start to escalate quickly. Mars, Earth, Venus, and Mercury would all feel its pull. The stability that has existed for billions of years would begin to unravel. Earth's orbit could become more elliptical, bringing it closer to the Sun at one point and farther away at another. This alone would cause extreme climate changes far beyond anything humanity has ever experienced. If the black hole passes close enough to Earth, tidal forces would become significant. These are the same forces that cause ocean tides, but on a much larger scale. The side of Earth closest to the black hole would feel a stronger pull than the far side, stretching the planet slightly. In extreme cases, this could trigger earthquakes, volcanic activity, and massive tidal waves. But let's consider an even more extreme scenario. What if the black hole passes very close to Earth, or even between Earth and the Moon? The gravitational interaction could disrupt the Earth-Moon system entirely. The Moon might be pulled into a different orbit, or even ejected from Earth's influence. Without the Moon, Earth's axial stability would be affected, leading to long-term changes in climate and seasons. Now here's something that might surprise you. Even if a black hole passed through the solar system, the chances of it directly colliding with a planet are extremely small. Space is vast, and the distances between objects are enormous. Most likely, the black hole would pass through, causing gravitational chaos, and then continue on its journey into interstellar space. At this point in the video, If you're fascinated by how a single invisible object could disrupt our entire cosmic neighborhood, take a moment to like the video, subscribe to the channel, and turn on the notification bell so you don't miss more explorations like this. Let's go deeper into what would happen to the Sun itself. If the black hole passes close to the Sun, the interaction could be dramatic. The Sun might be slightly perturbed, its outer layers disturbed by the gravitational pull. In extreme cases, some of the Sun's material could be stripped away and drawn toward the black hole, forming a temporary accretion disk. This would be one of the few times the black hole becomes visible. As the solar material spirals into it, it would heat up and emit intense radiation, potentially creating a bright, short-lived flare. From Earth, this could appear as a sudden and unusual burst of energy from a point in the sky. If the black hole were massive enough and passed close enough, it could even capture the Sun into an orbit, or vice versa. But such a scenario is extremely unlikely. More realistically, the Sun would continue on a slightly altered path after the encounter. Now let's think about the long-term consequences. Even after the black hole leaves the solar system, the effects of its passage would remain. Planetary orbits might never return to their original configurations. Some planets could be lost entirely, ejected into interstellar space. Others might settle into new stable orbits, creating a solar system that looks very different from the one we know today. Comets and asteroids disturbed during the encounter could continue to pose a threat for millions of years, increasing the likelihood of impacts on planets. The delicate balance that has allowed life to thrive on Earth could be permanently altered. There's also the question of detection. Would we see it coming? Detecting a rogue black hole is incredibly difficult. Without an accretion disk or nearby matter to illuminate it, a black hole is effectively invisible. However, we might detect its gravitational effects on distant objects before it arrives. Astronomers could notice unusual motions in the outer solar system, giving us some warning. But that warning might come too late to do anything about it. A black hole passing through the solar system is not something we could stop or deflect. It would be a cosmic event far beyond our control. Before we wrap up, I want you to think about this and share your thoughts in the comments. What part of this scenario do you find the most terrifying or fascinating? The idea of invisible destruction, the shifting of planetary orbits, or the possibility of Earth itself being dramatically affected? As we come to the end of this journey, it becomes clear that black holes are not just distant, abstract objects. Under the right circumstances, they could have a direct and profound impact on our cosmic neighborhood, while the chances of such an event happening anytime soon are extremely low. The possibility reminds us of how dynamic and unpredictable the universe can be. If you found this video fascinating, make sure to like, subscribe, and turn on the notification bell so you never miss another deep dive into the mysteries of the cosmos.